Hello. Today, for this lecture, we're going to talk about solving quadratic equations. Right? A quadratic equation is any polynomial that can be written in this form of ax squared plus bx plus c is equal to 0. Right? We understand that sometimes it may not be written like that to start, but our goal is to be able to get any equation into this form. Right? One term we're going to talk about a lot is the root. And the root, right, is any x value such that f of x is equal to 0. Right? Another word for a root is a 0. Right? It's an x value that makes our function equal to 0. So what we're really doing is we're solving this, right? We're finding the roots to these quadratic equations. And the three ways we want to solve them are factoring, completing the square, and using the quadratic formula. So let's work on our first problem. We want to solve this problem by factoring. X squared minus 2x minus 18 is equal to negative 3. Right? We said our goal is to get this equation to be equal to 0. So the first thing we're going to have to do is to add 3 to both sides, and we'll get x squared minus 2x minus 15 is equal to 0. Right? And as we said earlier in class, when we want to try and factor this, I'll look and say what two things can multiply together and get negative 15. Right? We have negative 1 and 15, 1 and negative 15, 3 and negative 5, or negative 3 and 5. So not only do we want to look to say what two things multiply to negative 15, but what two things add to negative 2, and that leads us to x having the values of 3 and negative 5. So we can factor this in x plus 3 and x minus 5 being equal to 0. And now that we have two products equal to 0, we can set them both equal to 0 separately. X plus 3 equals 0, x minus 5 equals 0, and we can solve both of these for x, get x equals negative 3, or x equals 5. Right? And these are our solutions. There is another way we can think about factoring, and this is what we call the square root property. And it says if a squared is equal to c, then I can take the square root of both sides, but I have to remember to include a plus or minus. And this is really helpful for any polynomial in this form. Ax squared minus c is equal to 0, right? Where the b of x is left out. So here's a case. 4x squared minus 9 is equal to 0. There's no x to the first term. So what I'll do is I'll add 9 to both sides and get 4x squared is equal to 9. Right? I can divide both sides by 4. I get x squared is equal to 9 over 4. And what I can do is I can take the square root of both sides. I get x plus or minus the square root of 9 over 4. And we can see that that simplifies to plus or minus the square root of 9 is 3, the square root of 4 is 2, and we can get our answer of plus or minus 3 halves. The next way we can solve quadratic equations is by completing the square. And this takes a little bit of steps to do. And so when we complete the square, we want the leading coefficient to be 1. If not, we have to divide the entire equation by our coefficient. Right, we want to move all the constant terms to the right side of our equation. We'll see why when we do an example. And what we're going to do is, what we want to do is we're going to have something like, for example, we might have x squared plus 4x equals 12 by the time we're done this step. Our goal is to come up with a value for this. And it turns out that that value is going to come from this piece being squared right here. And so how do we find what this value is? It turns out that this value in here is always 1/2 of that. So if this starts out as 4, the value that we can plug in here is 2, 1/2 of that. Right? Once we take this square, we're going to add that to both sides of the equations. And what it does is it's completed a perfect square trinomial, which allows us to write it as a binomial square, right? It's given to us in a form that looks like this, for example, right? Which is a perfect square like such. So it allows us to take a sum of three objects and write it as a square of two objects, right? We're allowed to just condense it like that, right? And then what we're going to do is we're going to solve. We're going to take the square root of both sides and find out what x is. So let's do this example by following our steps. We want to make sure that our leading coefficient is 1. It is, so we're good. Right, next, we're going to move all of the constants to the left side. I'm sorry, to the right side. So we're going to add 9. So if I do that, I'll get x squared plus 8x. And what we're going to do is we're going to leave a little space, plus something, equals 2 plus 9 is 11. And so what the next instruction said is, what we really want to do is make sure we can write this so it's a perfect square. And so this is our goal, to be able to say that this expression here is really the same as this perfect square. So how am I going to do that? Right? What it turns out we're going to do, like you said, is take this number and divide it by 2. So 8 divided by 2 is 4. That's the number that goes in here. If we were to expand this out, I would get 4 squared, which is 16. And that's the number I want to add there to make it my perfect square. And whatever I add to the left side, I have to add to the right side as well. So this becomes 27. Right? I can take the square root of both sides, but using my square root property, I need a plus or minus root 27. Right? We can actually simplify the square root of 27. Right? That's 9 times 3. Right? 9 is a perfect square. Plus or minus 3 root 3. So let me just rewrite this. I have 4 plus or minus 3 root 3. When I've simplified the square root of 27, I can subtract 4 from both sides. 3 root 3. And that's how we complete the square. Right, I know it's going to take a little practice, but we think whatever this term is, I divide it by 2 to get this value of 4. Then I want to square it, and gives me the value I need to add to both sides. Right? The easiest way to solve is definitely by using the quadratic formula. Right? This will work in every single case that we have. Right? So if we have ax squared plus bx plus c is equal to 0, what we can do is we can say that x is just going to be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So we can just do a quick example, right? X is equal to, well, let's see, we have to come up with our values. In this case, A is going to be 2, B is going to be negative 4. Notice how it's plus B, so if there's ever a different sign, that's included in our value for A, B, or C. And C is 1. We can just replace the values. So negative B is positive 4, plus or minus the square root of negative 4 squared minus 4ac, we'll extend that, all over 2 times a. Right? We'll just continue simplifying. 4 plus or minus the square root, let's see, 16 minus 4 times 2 times 1 is 8. All over 2 times 2 is 4. 4 plus or minus the square root of 8 over 4. 4 plus or minus the square root of, let's say, that's 4 times 2 over 4. Right? 8 can be decomposed into 4 times 2. That 4 can come out as a perfect square. Plus or minus 2 root 2 over 4. And a really common thing people do is they want to cancel these 4s. Right? We can't really cancel until we factor. So the first thing we're going to have to do is say what can be pulled out of the numerator. Well, the greatest common factor is just a 2. For 4, now I can reduce this and get 2 plus or minus root 2 all over 2. That'll be my final answer. Hopefully this video helps, and I will see you in class.